collections in C#. Next, types of collections. Inside this, we have a non-generic collections and generic collections. So we have seen data structures in C++, right? What are the data structures we have studied? There are stack, queue, array, array list, linked list, and there are searching techniques like binary trees, sorting. These are all the techniques we have studied, right, in data structures in C++. Okay, so here, what is collections here? Collections was introduced in .NET version 2.0. Okay, so in the .NET version 2.0, collections was introduced in C#. Okay, so there are basically two types of collections we have. And first of all, what is collection? Collection is a well-defined data structure. Okay, so we have seen data structures in C++. Okay, so there are some limitations. Okay, to advance to that, okay, we have collections in C#. Okay, so with the help of collections, we are going to handle our programs in our day-to-day life. Okay, now there are basically two types of collections we have. Okay, collections are well-defined data structures. Okay, there are two types of collections: generic collections, non-generic collections, and generic collections. So what is the difference between these two? Non-generic and generic. It's not type specific. It's type specific. Non-generic is not a type specific, but generic is a type specific. Okay, non-generic collections are non-type specific. Okay, but generic collections are type specific. Okay, now we'll see practically what is non-type specific, what is type specific. Now, when you have a non-generic collections, we can, this is dynamic in size. This is also dynamic in size. What is dynamic in size? If you see arrays, okay, we have studied arrays. What are arrays? Arrays is a homogeneous set of elements or group of elements with similar type. Homogeneous in the sense similar type. Okay, now when you specify the, when you create the array with fixed size, suppose if you want to add one more element to that, okay, we'll get the error. What is that? Array out of bound exception. We cannot add the elements during runtime there, and size is fixed for array. Now generic well-defined data structures. Okay, and okay, this is dynamic. There is no fixed size here. In like arrays are fixed size, but when it comes to collections, whatever it is, non-generic or generic, it is not a not a fixed size. It is dynamic in size. Means how many elements you are going to add, your collection is going to automatically improve its size. Okay, that's why I name it as a dynamic in size. And we can add or remove elements during runtime. So in arrays, okay, if you try to add or remove elements during runtime, we'll get error. It won't allow us. Okay, array out of bound exception, right? It does not allow you to add the elements during runtime. Whatever size is fixed, it use that much only. Okay, but here in collections, we can add or remove elements during runtime. Here size is dynamic, and if you consider non-generic collection, we'll use a namespace called using system dot collections dot generic. This is the namespace we'll use for generic collections, but sorry, vice versa. For this, no need to use generic, just system dot collection, since it is a non-generic collection. Thank you, man. Generic collections are well-defined data structures in C# was introduced in 2.0. Okay, so there are two types: non-generic collections and generic collections. So when it comes to non-generic collections, these are all non-type specific. No need to specify any type. Okay, and if it is a generic collections, while declaration itself, during compilation itself, you have to give the type. Okay, next, both are dynamic in size. You can add or remove elements during runtime. And if you want non-generic collections, you'll use a system.collection namespace. If you use a generic collection, you'll use using system.collections.generic namespace. Okay. Now, so in non-generic collections, what are the different types of collections we have? As we discussed, we have array list. Array list. Second, we have a hash table. Very, very important interview questions, guys. So when I have some 3 years experience, I went to one interview that is like in Bagmani Tech Park. Company name like Sun Biotech. So there was a team lead. He completed his interview only with collections. Only collections. He asked me each and every collection, and he asked me each and every program how it will work. Apart from these collections, he didn't ask me anything else. Okay, so that much important in our real time. That's why interviewer asked me those many questions in collections itself. Apart from collection, he didn't touch anything else. Okay, so that much important. Array list, hash table, sorted list, stack, queue. These are all the examples for non-generic collections. And what are for generic collections? We have for array list, we have a list here. For hash table, we have a dictionary. And we have sorted list as well here. And we have stack as well. And we have queue as well. Stack, queue, sorted list is available for both generic as well as non-generic. Okay. Now, let's see one by one how it will work. Let me create one array list now. Now, in non-generic collections, it is not a type specific. So what we have a class here, we have a array list. Array list equals array list. Okay. See here, it is expecting the data type. The type or namespace array list could not be found. Okay. Here it is expecting type. For non-generic collections, what is the type we want? Namespace using system dot collections dot. That's it. System dot collections. So then it will get enabled. So now, since it is a non-type specific, right? So you don't need to define any type here. Like generic, did we define any type? No. Now, array list dot add. Add is the method to add elements. I will give one string. Array list dot add. I'll give one integer 1 2 3 4. Next, array list dot add. So what else? Other types we have? We have Boolean, array list dot add. We have decimal, array list dot add. We have float. These are all the different types. Or array list dot add. Datetime dot now dot add this. I want tomorrow date. If you want tomorrow date, if you give -1, it will give you yesterday's date. Similarly, like this, you have add year +1 -1, not only one, next 10 years you want, or last 10 years back date you want, day you want, whatever you want, you can do with the help of date, time, data type here. Okay. So now these are series. It's not a type specific, right? We are adding the elements during runtime, right? We can also remove the elements during runtime. Okay. So now let me do for each. So you don't know the type. There is no type here, right? If you have some type here, while looping, you can specify the type. You don't know the type. That's why you will give where, which is a universal type in C#. Any type it will accept. Where record in array list or val in array list, value in array list. So let me print one by one val. That's it, to print those values. Now let me start. Function. So when you define array list, by default it is null. Nothing will be there inside this. Okay. Now when you initialize, okay, so by default count will become 0 because nothing is added as of now. So now what is the count? 1. What is the count? 2, 3, 4, 5, 6. 6 is the count. The index will start from 0 to 5. Okay. So now same thing I want to display. Okay. Understood, guys? Any doubts here? This is array list. Array list is not a type specific. Okay. How many elements you want, those many elements you can add, or how many elements you want to add. Based on that, this is going to add the size automatically. It is going to increase the size automatically. So like here, you can take a class as well. So those many objects you can add. So whatever you want. Okay. Now array start count. It will give you the count. Okay, count is 6 here. So next, so this is a list. So next, what is we have? We have list, which is a generic. Let's see how that list will work. Okay. So for generic, we have a list. For list, now, so list we need a namespace. So list is a generic collection. Okay. So to add this list, so you need a namespace using system.collections.generic. So now list, it is, since it is a generic, it will expect you the type here. It is expecting the type. Okay. For example, if you give int, so it is allowing only integer type. Other types it is not allowing, right? It is giving you the compile time error, right? So now you have to give the values only in the form of integers. So decimal float also it doesn't allow. So 1, 2, 3, 4, 5. Okay. And here, if you know the type, don't give where. Where also it will work, but it has to do the explicit type conversion. Okay. From it want to check which type it is, then it want to convert to that type and it is going to print. That is called explicit type conversion. Okay. When you use non-generic collections, so we got one more point, it do explicit type conversion. So in generic, we don't need to do explicit type conversion. You know the type, right? Just to give like this. So here, list. So if you give like that, it will change all the places. Okay. So now it will allow only integers. Now let's print this. One, two, three, four, 5, and the count is 5. So this is generic. Non-generic means you don't need to specify any type here. You don't need to specify any type here. Okay. So it can take any type when it is a non-generic collection. If it is a generic collection, you have to specify the type. Okay. For both. So how many elements you can add, how many elements you want, you can remove. Okay. That is not an issue. Okay. So for example, I want to remove something. So I printed. Remove. Okay. So if you specify some item, true, it will remove the 2 or remove at which will take the index position. Okay, for example 0 1 2 3 4, I'll give the 4, which will remove at fourth index. Now let's see. So this is before. Sorry. So as of now, we have 1 2 3 4 5, right? Now index out of range 4 0. Oh, sorry guys. Okay, so we have removed already 2, right? So the last index will be 3. We have removed, right? So before that, if we could have given at 4, then it will be fine. Okay, so now the last index, since 2 is removed, 0 1 2 3, 3 is the highest, 3. So it will remove item 2. It will remove item 5 at index list of 3, third index. Okay, at third index. Remove all means it will remove everything. Okay, let's start. Remove range. Range means starting index, after that how many elements you want. Okay, starting element from 1 to how many? 2. Okay, first element start index, or 0 to 2. 0 is the starting position. From that it will remove 2 elements, means 0 1 1 2 is going to remove if you use remove range. Then I have list start. So we will see one by one. It should remove 2 and it should remove 5. Let's see. 2 and 5 should not be there. After remove 1 2 remove 3 4 5 is also removed. Before count is 5 and now the count is 3. Okay, so now we'll comment this 2. I'm just commenting it, so later you can uncomment and check. List dot remove all. So here, let's see, remove all elements that match conditions. Predicate, we want to use predicate here. Remove range. Let's see reverse. List start reverse. Okay, which will reverse it. Next, list dot remove range 0 to 2. So previously we have elements Let's start. Remove all predicate. So we have to use predicate here and match. So whatever it matches, right? Those many elements it is going to remove. What are the match elements? For example, I forcefully move the decoder here. Continue. We'll come to next debugger. So as of now, this is our list. 1, 2, 3, 4, 5. Now, two got removed, right? So this is got predicate, guys. 1, 2 got removed. The matching element. Okay. So how many elements are matched with 2? For example, if you have a multiple elements. Okay, guys, this is I'm modifying as per my example. Okay, so this doesn't match. Okay, these things won't work like this because we are changing now. Okay, we have 2, 1, 2, 3, 4, 5, 2. After remove, we have only 1, 3, 4, 5 because wherever 2 is there, all the places it's got removed. Understood, guys? So that is about remove all. I'll delete this. I delete this as well or comment it.